Hello everyone, welcome back to my channel. I am Annapurneshwari Parit, second year CSC student at Shri Venkateshwara College of Engineering, Bangalore. And I am up with a new video of data structure and algorithm. And the topic is stack operation. Introduction to stacks. A stack is a linear data structure in which the insertion of new element and the removal of an existing element takes place at the same end, represented as the top of the stack. To implement the stack, it requires the maintenance the pointer to the top of the stack, which is the last element to be inserted because we can access the elements only on the top of the stack. Last in, first out operation will be performed on stacks. This strategy states that the element that is inserted last will come out first. You can take a peel of a plates kept on top of each other as a real life example. The plate which we put last is on the top, and since we remove the plate that is at the top, we can say that the plate that was put last come out first. Basic operations on stack are, in order to make manipulation in a stack, there are certain operations provided to us. For example, push to insert an element to the stack, pop which is used to remove the element from the stack, top which returns the top element of the stack, is empty of returns the true. If stack is empty, else it will return false. Size of will returns the size of stack. This is the picture of stack. First operation, that is push operation. It adds an element to the top of the stack. It increases the stack size by 1. For example, if we push element 5 onto an empty stack, the stack will now contain only 5. And it is the algorithm of push. Second operation is pop. It removes the top element from the stack and it decreases the size by 1. For example, if we pop the top element from a stack containing 2, 4, 6, the resulting stack will be 2, 4. And it is the algorithm of pop. The next operation is top, which returns the top element of the stack, and it is the algorithm. And the next operation is empty. It returns true if stack is empty, or else it will return false. Implementation of stacks. Stacks can be implemented using arrays or linked list. Array implementation is more common due to its simplicity. Linked list implementation allows for dynamic stack size. Array implementation. In array implementation, an array is used to store the stack elements. The top of the stack is represented by a pointer to the last element. The stack size is limited by size of array. The advantages of array implementation is that it is easy to implement, memory saved as pointers are not involved. And the disadvantage of this implementation is that it is not dynamic, that is, it does not grow and shrink depending on needs at a runtime. But in case of dynamic sized array, like vector in C++, list in Python, array list in Java, stacks can grow and shrink with the array implementation as well. The total size of stack must be defined beforehand. Linked list implementation. It is nothing but each stack element is represented by a node. Each node contains the value and pointer to the next node. The top of the stack is represented by head of a linked list. And the advantage of this implementation is that the linked list implementation of stack can grow and shrink according to the needs at a runtime. It is used in many virtual machines like JVM. And the disadvantage of linked list implementation is that it requires extra memory due to the involvement of pointers. Random accessing is not possible in stack. Time complexity of stack operation. Push, pop, and top operation on a stack have a time complexity of 0 of 1. The operations do not depend on the size of stack. This makes stack efficient for handling large amount of data. Applications of stack are Stacks are used in function calls and recursion. They are used for undo and redo functionality in text editors. Stacks are used in browser history and back button functionality. Stacks also help in implementation function call in computers. The last called function is always completed first. In memory management, any modern computer uses a stack as a primary management for a running purpose. Each program that is running in a computer system has its own memory allocation. Balancing parentheses. Stacks can be used to check if parentheses are balanced in an expression. Opening parentheses are pushed onto the stack. The closing parentheses pop from the stack. If the stack is empty at the end of the expression, the parentheses are balanced. Evaluation of postfix expressions. Stacks can be used to evaluate postfix expressions. Numbers are popped onto the stack and operators pop operands from the stack. The result is the value left on the stack after evaluating the expression. Infix to postfix conversion. Stacks can be used to convert infix expression to postfix expression. Operators are pushed onto the stack based on their precedency. The resulting postfix expression can be evaluated using stack. Undo and redo functionality. Stacks are used to implement undo and redo functionality in a text editor. Changes made to the text are pushed onto the undo type stack. Undoing or redoing an action involves popping or pushing onto the respective stack. Browser history and back button. Stacks are used to implement browser history and back button functionality. Each visited URL is pushed onto the stack. Pressing the back button pops the top URL from the stack. Summary of this video is that stacks are a fundamental data structure with a LIFO principle, which means last in, first out principle. Common stack operations include push, pop, and a top. Stacks can be implemented using arrays or linked list and have a time complexity of 0 of 1. Thank you.